So far over your mathematical lives, you guys have been learning about and talking about this group of numbers called real numbers. Real numbers like 0, 1, 0.3 repeating, pi, so on and so forth. We can go on forever. And now we just learned about something interesting. What if there was a number out there that when we squared it, we got -1? We defined that number as I, and we called it imaginary. Imaginary numbers can be like I, -I, 3i, pi times I. We took all these real numbers and we multiplied them by I to make them imaginary. So now, what if I combined these real and imaginary numbers so that they became sums and differences of other real and imaginary numbers? What would you call that? They're called complex numbers. Complex numbers such as me taking real numbers, 3, and adding imaginary numbers. This is a complex number, and you might be tempted to add these two, but you can't. Do not do that, because these are as simple as they get. We cannot add real numbers to imaginary ones. We can multiply them, because that makes it an imaginary number. We can't add the two. So let's pick out the parts of this first of all. This is real. Your real part. And this is your imaginary part. So what good does that do us? Well, this is going to become very important in the future of this lesson and of your math careers. But let's start by talking about making them equal. If we have two of these, two complex numbers, let's talk about making them equal. So we're going to be equating complex numbers. I want to make these two complex numbers equal. Well, first, how do we know when that happens? Two complex numbers, like this one and this one, they can only be equal if, and only if, their real parts. What are the real parts? 3x and 6. If those are equal, and if their imaginary parts, like in this one, 5i and 10y, if those are equal too. Our real parts need to be equal, and our imaginary parts need to be equal to each other. So let's make these two complex numbers equal to each other. First, I want to start by pointing out what are our real parts and what are our equal parts. Like I said, 3x and 6, those are the real parts. -5i and -10yi, those are the imaginary parts. So now, my first step in making these two complex numbers equal each other is that I want to split them up into two different equations. One equation using my real numbers, and another equation using my complex numbers. So I'm going to use my real numbers first, and I'm going to have 3x is equal to 6. And then over here, I'm going to have my other equation being -5i is equal to -10y times I. Let's solve for x first. Dividing each side by 3, I know that x will equal 2. Then look over here at the y side. Well, we have a negative 5i times negative 10yi. I'm going to divide by a negative 1, leaving me with 5i is equal to 10y times I. Now, I have an I on both sides. I'm going to divide by I, leaving me with 5 being equal to 10y. My next step in getting y by itself, I'm going to divide both sides by 10. And then I'm going to simplify because I'm going to have 5 over 10, so y is equal to 1/2. And now, if we were to plug these numbers in, these would be equal to each other. We'd have so x equals 2, y equals 1/2. 3 times 2, 6, minus 5i is equal to 6 minus 10 times 1/2, 5i. We're done.